Hi you guys, if you are stuck on this problem, I want to walk you through it. It's a little bit different because we're given a volume and mass instead of a concentration. So we're going to have to do a little bit of back work here. So first it says at 1,285 degrees Celsius, the equilibrium constant for the reaction bromine gas turns into 2Br gas is Kc 1.04 times 10 to the negative third. So Kc tells me that we are working with concentrations here, and concentrations are in molarity. So this is moles per liter is what we're working with. Okay, so first we're going to write the expression. So the expression for Kc is products. So bromine raised to the coefficient over reactants. And since the coefficient is 1, it's just Br2. So that is what we're going to be placing our values into for the next problem. So it says a 2-liter vessel containing an equilibrium mixture of gases has 0.245 grams of bromine in it. What is the mass of the Br in the vessel? So we know our Kc is 1.04 times 10 to the negative third from our problem. And what we know about the Br2 right now is that it is 2.45 grams and it's in a 0.200 liter vessel. So in order to plug that in to the equation here, it needs to be in molarity. So right now we have the liters for the bottom, but we have grams on the top. So we are going to use our molar mass. So hopefully you have your periodic tables handy. So when I look at my AP periodic table, I see that bromine is 79.90. And there's 2 of them. So 79.90 times 2 is 159.8. So 159.8 grams in 1 mole. So I'm going to take 2.45 divided by that answer. And I get 0.01533 moles. And I have 0.200 liters of space. So that has a concentration of 0.07. Let's see, how many values were we given? 3, so 767 molar is our concentration for the Br2. Okay, so what I need to do then is plug the 2 values that I know into my equation and rearrange for the concentration of bromine. So I'm going to get, let me show you my work here. I need to get the bromine by itself. So that cancels. And then to undo the squared, I'm going to take the square root. So Br is equal to the square root of, oh, sorry, that 2 should be on the inside. Let me put that on the inside here. Okay. Is equal to my concentration of Br2, 0.767, times my Kc value, 1.04 times 10 to the negative third. So I'm going to do the inside first. And I get 7.97 times 10 to the negative fifth. And I'm going to take the square root of that answer. So the concentration of my bromine is equal to 0.00893. But that's my concentration. So that's moles per liter. So what I want is the mass of that bromine gas. So now I am going to get my moles to grams. So for every 1 mole of my Br, that's 79.90 grams. So moles cancel. And I also need to get rid of my liters. So I know that this is a 0.200 liter vessel. So that will get rid of my liters, and I'll be left with just grams. So bromine ends up being times 79.0 times 0.143 grams. When I compare to my bromine gas, the bromine gas was 0.245 grams. My bromine is 0.143 grams. This makes sense to me because it's a lower concentration. It also has a lower molar mass.